Good evening. Uh, Welcome to this course on FOSS for G. Today we are going to discuss about free and open source software for web GIS. I am Shiva Reddy and I will be taking you a brief about what is web GIS, then what are different components of web GIS and how FOSS for G solutions means free and open source software solutions for web GIS which are available and what are the related terminologies, and I will quickly brief you through different components which are available in the web GIS. Then finally I will come how you can use or how people are using this free and open source software for different use cases. Like one is for humanitarian OpenStreetMap team. This project is very famous because whenever any humanitarian crisis occurs, this hot project create that project and people like us can contribute for disaster support and response for the community mapping. Then OpenAQ, another project where basically I tried to use different diverse case studies. So OpenAQ, basically this platform uses a free and open source software to display the real-time air quality data around the world. We'll see how different Internet of Things sensors, IoT based technology can be used to integrate different sensors, like here in our case real-time air quality sensors of different make are integrated into one platform. Then third case study, QRealTime, I'll just explain the in-house developed plugin for QGIS which help you in real-time data collection and mapping. Then we'll conclude. So if you see what is WebGIS, is a type of distributed information system. Why? Because WebGIS resources are distributed, but in layman term, if I have to explain, I can explain simply. In WebGIS there are two components. One is a server, another is a client. So there should be at least a server and at least a client. In layman term, we can say this is a web component, and generally because it's a GIS means we use that to disseminate, edit, create, manipulate the spatial data. So typically server would be web server, in our case normal web platform, and in WebGIS along with web server and GIS server. Then client, so there can be many clients. So there can be one server, many clients, there can be N server and M clients. So there is a lot of combinations, but client can be a web browser, client can be a desktop application. So often we think that in web client is only your web browser. No, there are many desktop applications which in turn is connected to internet and fetch resource or communicate with the server. So they are called desktop applications. Then similarly there can be a client which is a mobile application. So web browser, when I say, it can be desktop, mobile or anything, but there are applications, mobile based applications which can also interact with the web. So if you see architecture here, simple architecture which I try to explain, you have a database. Here also yesterday lecture you might have studied in detail about PostgreSQL and PostGIS, so database installed. So then there is a WebGIS server like a Geo server, again it's an open source solution. So it is connected to database and it is through here Apache Tomcat is a web server, basically we suppose HTTP protocol. So through web server, by using web browser you can connect to your WebGIS server and interact both way, right? So client, who is a client, who use client software like web browser, and then while in web server you develop application, this application consists of HTML. Apart from HTML, to add dynamism and to have a visualization and other complex use cases which is not by default supported by HTML, are supported by open source JavaScript library like OpenLayers API or any other JavaScript library. Similarly, you see here there are another set of users who basically publish the data. They use shapefile or raster data. They can ingest into database. Through database it is connected. So that is one simple example I want to explain how WebGIS works. So when you are using a commercial software or a proprietary software, then generally you try to have a vendor lock, or you try to use all the software and data sets compatible with that software. But what will happen is when there are multiple users, multiple organizations sharing data, and which generally in desktop scenario may be rare, but in web environment you are always connected to internet, and there are lot of kind of users, kind of entities who are generating data, kind of users who are consuming data, and all of them need not be have a using same software or same packages. In that kind of scenario, interoperability become very much essential. And for this, in Open Geospatial Consortium plays an important role, and they have made multiple standards. So the standards which are related to WebGIS are called one OGC OWS, OGC Open Web Services. Under this you have different services like WMS, Web Mapping Service, WFS, Web Feature Service, Web WCS, Web Coverage Service, WCPS, Web Coverage Processing Service, WPS, Web Processing Service, and Catalog Service for Web. So these are different kind of open web services standards. So what is the advantage of these standards? It means whenever I am communicating between the system or between a client and server, irrespective of what my client is built with or what my server is, the communication will follow a common standard, and that standard is made by OGC. Similarly, you might have noticed that most of the open source software or the proprietary software supports the different file format like shapefile, GeoJSON, you have spatial light, you have a geo package. So these file formats which are used to store the data are again open OGC compliant. It means the file created in one software can be used in another software. Similarly here, these services, if you want to access mapping, feature, coverage, anything, these services are compatible across. So that's why, but when we talk about open source, free and open source software, this standard become more important, because the idea behind free and open software is that not only software, we also provide the code, and we expect user of the software to contribute in the development of the code. And in that scenario, sometime there can be multiple projects which both of them together can work and fulfill the user requirement. So if every software follow their own standard, then interoperability become issue. So that's why we have a different not-profit organization which make standards. So, and recently there are separate API based standards, how to create different APIs which are beyond these open web services, that also made by the OGC. Those who are interested can follow the ogc.org website. So now coming back, so till now we understand about the what is WebGIS and what is OGC standards. Now coming back, while OGC standards are equally important for commercial and free and open source software, but because free and open source softwares don't have say any proprietary or any company or profit organization which basically take care of that product, therefore for the geospatial requirement, there is an entity called Open Source Geospatial Foundation. So this is called OSGeo Foundation. This foundation is non-for-profit organization which enables the participatory approach, community-driven development of the software packages, and its mission is to empower with open source geospatial, empower everyone with open source geospatial technology. For that, the major concern of price and proprietorship is take away, and OSGeo Foundation supports, and there are a lot of generous donors like individuals or organizations, country which support this OSGeo Foundation. So most of the software packages or WebGIS open source packages which I am talking about are funded or supported by OSGeo, right? So if you look into that, WebGIS, if you broadly categorize, what are the three components which is required? One is content management system, another is called metadata catalog, and third is web mapping. So let me take a while to explain what they mean. While CMS, content management system, is such a software packages which enable you to dynamically update your website, in our case WebGIS application, without doing any development. So suppose you want to add some layers, you want to remove some layer, you want to enable some functionality, you want to disable some functionalities, and you have a predefined theme or framework where you want to publish, create an application. So in that kind of scenario, CMS helps. So content management system, like any enterprise organization, similarly GIS based application development, lot of companies use content management system, because here you can focus more onto the data, the functionality, user interface, rather than developing the user interface. Here you decide what component you want to expose to the user, what component you don't want, how it would be organized. So without much of development, if you are using CMS, you can do rapid publishing of your application. Second one is very much important. So now suppose your aim is to not develop applications, but your aim, whatever data you are publishing, it will have a metadata. Metadata means it's a data about data. So now it is not possible for any single entity to store entire data sets available in web. It means suppose there are hundreds of WebGIS servers available within a country, and all of whatever data is there, I cannot store say at a single place, right? So suppose someone want to search what are different data. If I start searching in the entire data, it will take a lot of time and computational resource, and maybe in the feasible time you will not be able to extract the data. But in the metadata catalog, what happens is the metadata about different servers, data sets, all of them are stored. And to organize this metadata data, there are some packages or softwares which we call come under the metadata catalog. A metadata catalog help you in finding the data, not only the data, where that data is and how to access it. So that kind of data you can access through metadata catalog. And third one is when you want to actually, in web content management system, map is not created by you, you just simply add layer, and based on the CMS configuration automatically maps are generated. But sometime you want to generate custom maps, you want to publish a map, you want to create data, add some legend, and at the same time something you want to do server side, something you will do with the client side, and this is called web mapping, basically using map for mapping. So mapping is not only visualization, data creation, data editing, whatever you want to do, we call as a web mapping. So these are three components, and we'll see this entire umbrella of these three components, how you can use free and open source software based on your requirement. So one of the example, if you can see here, is for content management system is GeoNode. So using the GeoNode, you can use all the functionality which completely GIS platform have, and these functionality you can provide data, metadata management, you can do mapping capability. So without installing a GIS software, basically when you are using WebGIS, you are not installing any GIS software, because the GIS component is handled by the GIS server. But through a browser or a lightweight client, either desktop based or mobile based client, you can access the data, you can manipulate data, you can create maps. So all of this, and at the end display them in a dashboard, can be done with using CMS, as I explained earlier, without development. So GeoNode is such an example. Another example where some slight development may be required is a map blender. So if I see here, so GeoNode again provide you all of the functionalities. Similarly, map blender is again place where you can create maps. It acts as a content management service. At the same time, it provides other functionality also. Then I was talking about metadata catalog. It is very important because the quality of the data, the source of the data, the provider of the data plays many times very important role than the actual data. It's like if you are reading a tweet from BBC, or you're reading tweet from your state government, or you're reading tweet from some individual, so all of them may have different weightage. So many times it is the source of the information which define the credibility of the information rather than the type of information, right? So metadata catalog is very important because it tells you the details about the data, and also helps you in easily accessing, because metadata is smaller than data. So your data may be 1 TB, but your metadata may be simply 200 KB or 10 KB. So managing metadata is easy, because size is less, you can easily index and search. So often when you want to find out any data, you don't search on the entire data collection or database, but rather you search on the metadata catalog. This is similar to if you want to read a book, you first read its index, then you go to the chapter by referring the page directly. Similarly, if you want to access any geodata, before visualizing or loading or downloading the geospatial data, you browse through the metadata, and for that there are different software packages available. One GeoNetwork package is there which you can install, and it work as a intermediary between the data across multiple catalogs, and you can create multiple catalogs. You can add it provide tools to create a catalog. But only disadvantage is, as I said, GeoNetwork has its own user interface, and because there are a lot of things it need to be do, lot of functionalities are there, so it become bigger. So sometimes GeoNetwork itself size would be equivalent to a geo server or web server size. But nowadays people are more while the graphical user interface is important, but there are many scenarios where you want to do automation. You don't want the user to enter something and search. You want your program to automatically search in the metadata, right? In that kind of scenario, the entire the GUI component, other GUI and other complex component which is developed available with the package like GeoNetwork and other become redundant and useless. In that scenario, what you can do is we have an open source solution for such kind of scenario. It's called PyCSW. So catalog service for web, which is a standard, and we have a PY for Python. So Python CSW library is there which you can install. It is simply 400 KB size. So easily within a second you can install, and you can create multiple metadata catalog. So now software package is very small, but of course your catalog depend on how much data points you enter, it can run, and in single installation you can create multiple CSW endpoints as I explained in here. So because no GUI is a simple, it's a scriptable, so lot of users who want automate the data search and visualization can use PyCSW. So one GeoNetwork, if you are a traditional user, you want to manually search the data by typing, your requirement is very less, you can use it. But you have organization or requirement is such that you dynamically want to search, and through your program you want to search, so you do the GeoNetwork may not provide you such strong API endpoints and faster search results. So in that scenario you can use PyCSW. Again, this is also free and open source packages. You can just install by pip install PyCSW, and this will be installed, and then you can follow his documentation to create a simple endpoint. And to be noted, it's a simply 400 KB size. Third one is very important, if not the least. Like we have a for web mapping, what you require. Web mapping, the two things which you require is, you require a server which helps you in data publishing and other. You require a client side JavaScript library which help you in making it user friendly and adaptable interface, right? So most of the interface is generally made in the client side. So if you see, the open layers is a very famous API. Similarly, suppose you are Python based. Now again, if you are open layer, you are a conventional HTML and JavaScript based application developer, or you want your organization want to develop something. So open layers will provide you lot of solution, ready-made solution. It may happen that you don't need to do whatever you want to do is already example code is available. You just need to integrate with your server and you will able to work. But if your backend data or interface is in Python, and now you want to do some processing in Python, and but you want to publish them as a web service, then PyWPS can be used. Similarly, we have different packages, like one server is map server, another one is geo server. So these are two servers which basically this package, if you install in any hardware geo server and configure its domain name and IP and everything, that hardware will become a GIS server. Simple as that. So you can install geo server in Linux based system, or you can install geo server in right So this is GeoServer website. Here you can always see that you have a stable version, you have a maintenance version, and your development version. So development version will be most most feature rich. Latest feature would be there, but there may be some bugs because they are less tested. While stable version, it is chances that they are again, this is nightly build and this is nightly build. So stable version is the tested one which passed, and maintenance is where long term support is provided. So generally LTS, long term support software, or stable latest software, and development software. So generally these softwares are shared. You can download and install for any of your platform. At the same time, if you want to do any development, you can look into its source code. Similarly, if you see map server, so map server is the, I will say, the older version of the before GeoServer. Map server was very famous. Nowadays also there are some functionalities for map server. You will find out that they are more user friendly or more compatible for other application. So because they parallelly developed, both are supported by OSGeo, but map server and GeoServer are different. Like map server development and other thing is based on C and mostly on the C, while GeoServer is completely written in Java, right? So for a user, you may not find difficult much difference, but if you want to develop some application, the steps may be slightly different. Those who are interested, then follow them. But generally, for small scale project, you can always rely on GeoServer, and when a large scale project or you have a lot of raster data to handle, you can go through map server. Now another package is PyGeo API. Again, deliberately I am talking about two kind of software. One software which is required by the end user who don't do any development, who don't want to get his hand dirty and directly start, like you install GeoServer, upload the data, publish the layer, and you can use the different tools, style layer, description, other files in generate and create a beautiful map in GeoServer, and that can be accessed through a client like OpenLayer and other. Second kind of user who want to generate these layers dynamically from a Python program, right? So for them, again, interfacing with this will be a difficulty, right? So like here, PyGeo API, it provides all the OGC API suites of standards. So if you are developing any API using PyGeo API, by default it will follow the OGC API suites, and it supports a lot of Open API, GeoJSON, HTML formats, so that you can simply install this library and you can make a server which and share your data. So simply Python based library, you can create your server and you can share your data, right? So this again, the PyGeo API is a non-GUI based API endpoint service providers, right? This is also freely available. You are free to use. Now if I click on OpenLayer, because till now we are talking about servers. So if OpenLayer is a project basically which provide it is a JavaScript library which provide a rich API for mapping. So though you can easily follow this OSGeo link, and those who really want to dig into further details, you can open this project resource, you can see how to get started. But again, this project is also supported by OpenLayer, and it's a JavaScript library. For the brevity of the course, and here in this course we cannot cover what is JavaScript and HTML, but to understand is that the client, the web browser mostly, it can only understand two things. One is HTML, and HTML is a scripting language, so you cannot do any programming or logical operation there, right? But if you want to do any logical operations, only option you have is to write a code in JavaScript which inside HTML, and that can be read by your web browser. Your web browser cannot read the Python, C or any other programming language, but it can understand the JavaScript, and JavaScript is not full-fledged programming language. That's why it is called as a scripting language, because it has some limitation. And now using JavaScript you can do a lot of if and buts and logic. So using that logic also you can create a visualization of a map, but again it will take a lot of development work. So to avoid that, the JavaScript library, OpenLayer's JavaScript library is there. So here simply you have to tell what you want to do, and how to do it is implemented by OpenLayers, right? So while OpenLay is a client-side library, PyWPS again, this is server-side library. Again, if you go for OSGeo Foundation website, you will get link of the all of them. I will maybe once demonstration is over, I will show you the OSGeo website also, right? So PyWPS is server. Then Degree is another server. If you see Degree, so till now GeoServer means what you are doing is you are using GeoServer, GIS server for publishing your data as a web services, and through web services standard this data is accessed by your web application, and that web application based on requirement is developed and user can access it. While Degree is it provides a spatial data infrastructure. So if you want to create an infrastructure like a country level, state level, where lot of kind of data you want to store in a single place, so GeoServer or map server may not be sufficient. You require a software which you basically which we call as a SDI, spatial data infrastructure, which not only provide you web mapping capability but also metadata cataloging services, so that you can catalog the metadata, and the lifetime management of the entire data generation to data version control, and the security and the access control. All of these are, so you can see that compared to GeoServer and map server, Degree and other which are basically called SDI, spatial data infrastructure softwares, they provide much more functionalities to develop end-to-end repository of spatial data. So Degree is one such, right? So then another package is GeoMoose. Right. So again, GeoMoose, unlike a GeoServer and other PyWPS, map server, they are, while server side, GeoMoose is a client side JavaScript library, and while OpenLayers also is a client side JavaScript library, but you need to access the different web services and other, and develop UI using the only OpenLayer. You cannot develop the UI. OpenLayer, only what you can do is you can connect to the server and fetch the data layer, but for visualization you may require further another JavaScript library or some JavaScript code. While GeoMoose code provide you lot of things pre-built, right? So this is recent one is released on 29th July, and they provide you much framework, basically like a dashboard, like a content management system which provide end-to-end solution. Here GeoMoose provide you client-side infra framework to develop client-side applications. Right? So you can develop different modules. So you can add one module, delete some modules, some ready-made modules are there. So it provide large-scale application development if you want to do. You may prefer using GeoMoose for enterprise users and OpenLayers for individual users, individual application, small scale you can use that. So GeoMoose again provide you client geospatial client framework. Using that you can develop different web applications. So far what we are talking about is what are different packages, what are different software which help you in developing WebGIS applications or use WebGIS for any purpose. Now coming slides, what we are going to look is, we are going to see how these technologies are used by different people. So if you see the HOT, Humanitarian OpenStreetMap project, so what happens is whenever there is any crisis or anything is there are lot of community and organization, lot of projects are made. So there are, if you see, there are so many community mappers, there are so many map edits done, so more building is developed. So currently what project we are working with, if you want to see, so you can see that So you can basically this humanitarian OpenStreet mapping project use OpenStreet mapping software and use this to create different mapping hubs. Like there are different communities for each geographical region: American, Latin American regions, Eastern and Southern Africa, Asia Pacific. So these communities are helping to develop different mapping solution for different requirement, right? So if you want to start mapping, say you can create data, you want to contribute to this project. So you can see what are different kind of projects are working. So recent earthquake in Turkey which has happened. So there are as soon as anything happens or this humanitarian OpenStreet mapping project, what they do is they create that project and enable all the users to contribute to data. So I know during disaster, creating data may not help the actual user directly. But what happens, there are a lot of people, say people like Red Cross, people like disaster management or disaster rescue force, all are there. They go to field and to search and rescue people. But people from outside or people who are there, if we can map them, create maps, so this project helps them in getting the latest information. So whenever they go there and if they want to know what are the location where the people are reported, so without location for them to optimize their response time will be difficult. So that's why hot team provide a project where you can click in on it, anybody can join on it, and then you can map the data, you can download these things. So for this project, if you see how much contribution has been done. So some people are contributing, some people are validating. At the same time, some people are simply downloading this data. You can download entire data sets and this data is used by different people who require data. So if you cannot provide service, at least you can provide your information. Say you know that your neighbor, some building has collapsed, so that or you know that something happened in front just 10 streets away, so you can map that so that next people who is dire need of this data can take it. So there are multiple projects. So people like us or some people, the volunteers, keep contributing to this data. So this is one example where open source software with the community. So generally open source software are developed for community, but now community uses is for different purpose here, but it is developed for community by the community, and data is used by also the community for the betterment of the community, or the anytime humanitarian action is required, this project is used. Another example, OpenAQ, basically open air quality portal, and using this portal you can see how different data works, how the data distribution is. So if you want to see here, so if you want to explore the data, you can see here. Though it's a beta, basically they are providing the data you are interfacing, and they provide a API similar to OGC APIs, and this API can be used by different people. So say you have a lot of sensors in US, lot of sensors in Western Europe, and some sensor in Eastern Europe and nearby India, Bangladesh, Pakistan, and there are a lot of sensors you can find out in the Laos, Thailand. So these air quality sensor, if you click on any place, you get what is the different level, right? And if you want to show the detail, you can see what is the different status, what kind of data are available. So for this you can see that data is not there. Similarly, let me go here, right? I can see here different measures are there. If I go on show details, I can see the detail. So I think let's go some here. Let's go to Turkey, right? So O3, SO2, these measurements are there. Those who want, you can watch the data. currently data is not here, but I will just check it out. Right, say this color coding, PM 2.5 level color coding, if you see, darker means there are more of such data set, right? So but unfortunately latest reading is not available. No problem. Similarly, though data sets are, lot of data sets are here, okay, though we are not able to see here in the details because it is in beta, maybe some testing is happening, but you can see that how map is created. So currently map is created based on PM 2.5 level. So if I, in place of PM 2. If I say PM 10, so this map is updated. So now PM 10 level, this is the data sets, and similarly say I want to see CO. So where is the data? Yeah, only Northern America I can see the CO data. O3, if you like here O3 sensors are there, so Europe we have less sensor, and based on this graph you can see which have more pollution, NO2 level if you want to see, right? Again here I can see NO2 levels. So different based on different thing you can just browse it. You can choose the data providers also. You can select different data providers services across available, and you can select all or you can select none. So there are a lot of options, and for developers particularly this project, you can fetch this data through APIs and develop your own user implementation, or you can automate the service. So here this also not only use the free and open source software to develop this application, they also provide open APIs so that you can work on it, right? So till now we are talking about two application scenario. Third one is the development scenario. This is the in-house developed plugin. So what we have done is now people go to web, collect data. People use mobile phone to collect data, right? So many times you need to when you are digitizing in GIS, you require to have some data with the field. So one option is you go to field, mark it, then again same thing you have to mark in GIS, your GIS layer. But for that, like ODK based solutions you can use to collect data directly from mobile phones or from the web browser, and this data is aggregated into a centralized server, right? So once data is aggregated into centralized server, this data comes in different format, and then what will happen as a typical GIS workflow, you download it, you select the lat long field and other thing and geocode it, then your layer will be ready, and then you have to do lot of further operation for filtering the data. So in this scenario, what in IIRS we have done is, we have again like first lecture you might have studied about QGIS is open source software, and QGIS comes with a license which is called GPL, General Public License. What does this mean? General Public License tells that any software which is GPL, if you share with anyone, you need to share that with the not only executable but also the source code, and the person who is the recipient of this GPL software, say our case QGIS, the license dictates that anything which is derived or add on top of that must also be GPL. In the sense, suppose you develop some extension to the QGIS, you want to share with others, so again that should also follow GPL license. It means not only that extension executable but also source code need to be shared. So that this is called GNU public license. So this public license insists that whatever derivative you develop using the open source software must also be the open source. While LGPL license, which is called limited GNU public license, which tells that suppose you are using a QGIS, any LGPL software and developing something like GDAL comes under the LGPL category, or LGPL like LGPL license, which are lesser or which are somehow less forcing to make open source. So you can use GDAL like packages but develop a custom software. So but the main GDAL component, whenever you share, the GDAL original one need to be open source, but the derivative need not to be open source. So derivative can be your proprietary, you can protect your derivative license. But QGIS, because it follow GPL license, all the plugins are again follow GPL. So we have developed a plugin which extend the QGIS functionality, and what it does is it convert your GIS layer schema to a ODK form and upload to server, and by doing that, all the mobile apps which are related with the ODK server can collect the data, and once data is going back to the server, aggregated, the entire data which is collected. So you have 100 submission, means 100 same form, 100 people have filled the data. This or so means basically, say in geospatial environment, 100 points are created. All 100 points along with attribute data is at the server. Now this plugin automatically download this data in a single click and convert into a GIS feature and add it to a GIS layer. And we also provide the sync option so that regularly to check for any new update are there and try to download, right? So those who are interested in web mapping or real-time data collection can follow this link, Q Real-Time. This Q Real-Time plugin, which is available in QGIS. You go to QGIS plugin manager, Q Real-Time, you can click on home page, you'll get to this place. From there, entire data sets, how to develop it, how to use it, and how to configure different kind of open source software which are available. So there are Kobo Toolbox server is there, which is freely open source available and hosted by UNOCHA, United Nations Office for Coordinating Humanitarian Affairs, UNOCHA. So UNOCHA hosts the Kobo Toolbox server. ODK Central is hosted by again ODK, but what you can do is you can install your own ODK Central instance, or you can use the clouds hosted Central API and pay some money for hosting service and use it. So Kobo is free, ODK Central is free but not hosted. Similarly, ODK Aggregate is also similar product by the ODK, which you can install and configure and use it. So for any details, you can always find this, and you will find our contact details where you can contact. So what so while two application, we see how you can develop web application using the, like here they are using OpenStreetMap, Map Blender and other open source software packages to develop web application. Here also we have seen that they use that to develop a web application and develop API. And third case study, we have seen that we are using free and open source software to develop another software which in turn enable users to collect data. That is the power of the open source software. Not only you can use it, but some of the user who can develop, who can learn, they can contribute to and enhance the functionality. So QGIS without Q Real-Time plugin cannot connect to ODK and cannot do real-time mapping. But if you connect to Q Real-Time plugin, you can do real-time mapping. So there are different set of users. One who want to use this software package can directly use. Who want to develop some application, they can do. Third kind of software users are those who want to use these tools, at the same time contribute something and develop some tools on this. So this Q Real-Time is such case study example which is developed inside in IIRS, right? So finally, if I conclude, free and open source software, for particular WebGIS or in general, they provide you always free and community supported software tools, right? So they are always free, but they are supported by community, right? Unlike proprietary or commercial packages, the service and support can be sourced from any vendor. So generally what happens is proprietary software or the packages, commercial off-the-shelf packages, their service and support will be provided by the person or the vendor or the firm which developed this software. But here, as I said, free and open software, though because they are free, they are community supported. But suppose you want a commercial solution or service provider in a commercial term, because you yourself you are not satisfied with the community, your requirement is such that you require a real-time service and support. So you can use paid service from any vendor. So that freedom. So not always means because free package is there. So not it is not necessary that always you will get a free support from community. So sometime if your requirement is such, you can go for paid service also. Similarly, what happens like institutional users, organization, governments, if they want any free and open source software, or if they want any software So either they can buy a proprietary software or commercial off the shelf packages and use them for their requirement. But sometimes what happens, there may be some features which are not there in the proprietary software. So you may need to hire a developer or some organization to pay something to develop that custom solution. This custom solution, whatever you paid, this custom solution would be sold to you, and again this later what can happen is, because that solution is sold to you, that solution can be used by only you, and there is no source code available with you. Though you have funded that specific that feature, the source code is not available with you. But another scenario, consider another scenario, you require some feature which is not available in any software. You you choose any free and open source software like QGIS or GeoServer, and you fund them or their organization like OSGeo Foundation to develop some feature. So what will happen is, this feature will be developed because you are paying it. You will be at your satisfaction, the feature will be developed, you will be tested, and you can use this feature. At the same time, the development is not going to waste, because that developed feature along with source code will be available in the open source community. So other organization or institutional user need not to pay for the same feature. So what will happen is, the institutional user or large organization can keep sponsoring new features in place of wasting the same features which is developed in other commercial software and funding and refunding again. And finally, as any society, any culture, openness promote innovation and inclusiveness. So if you are using open source software, there are high chances that, because lot of users have given freedom to contribute, so there are high chances that more innovative solution will be generated, and it empowers the weak and the resource constrained people also to use your software. So that's why it includes inclusiveness. And out of these users, many times the needy and the resource constrained users are the one who develop innovative solutions. So that is the idea or thinking behind free and open source software. I hope after seeing this lecture you will be encouraged, and you will find out, if you have any, till now if you think you were thinking that you need to buy a software or you need to invest lot of money before you can start developing any web application or host any data. So without doing anything, freely you can use this free and open source software and develop wonderful WebGIS application. Thank you.